In this video, we're going to look at using multimedia to optimize learning. So the primary theory that is going to inform our strategy for multimedia learning is called cognitive load theory. And this was a theory that was developed by Sweller, who was an Australian psychologist or educational psychologist. And cognitive load theory has to do with the way that we learn information. The central tenet of cognitive load theory, if you really want to break it down to the basics, is that we can only process a limited amount of information at any one time. And our goal when we're talking about multimedia instruction is to use multimedia to guide learners through their processing of new material that they're learning. So let's discuss the types of cognitive load that are happening as a learner is engaging with new material, as put forth by Sweller. The first type is intrinsic. And the intrinsic load is just the inherent difficulty of learning a new subject for a student. As an instructional designer or teacher, we can't really change the amount of intrinsic load for a given topic, but what we can do is manage the amount of intrinsic load that a learner is having to deal with at any one time. And often we do this by breaking apart a complex subject into smaller pieces so that a learner only has to tackle one part of that at a time, and they can form what are called subschemata. And that's basically breaking the more complex subject down into smaller, more manageable pieces. The next kind of load is the extraneous load. The extraneous load are any extra details that the learner is devoting mental processing to that are not necessarily helping them to learn or retain the information that we want them to. So what we want to do with the extraneous load is we want to limit that extraneous load as much as possible and even eliminate it if possible. The last kind of load is germane. And the germane load is the relevant learning and relevant processing that a learner is going to do in order to form the schemata and the mental model so that they can really understand the subject that we are trying to get them to learn. So for the germane load, we want to maximize the germane load. Now there's only a limited amount of processing that a learner can be doing at any one time. So in order to maximize the room that's left for the germane load, we're limiting the extraneous load and managing the intrinsic load. Another very important concept that cognitive load theory is built upon is dual coding theory, and this was an earlier theory that Sweller built upon. So dual coding theory has to do with the idea that our brains, they actually can process two channels of information at any one time. So we might have channel 1 and channel 2 both going into our minds, and we're processing the information from both of those channels simultaneously. And remember, when we only have a limited amount of load at any one time, that space is very precious, and we want to make sure we're using both channels efficiently. And the two channels that we're dealing with are the visual and the verbal. The visual is what you might expect. It has to do with imagery, graphics, pictorial representations. anything that is not engaging the linguistic center of our mind. The verbal information is that linguistic information, and that is in both auditory form, such as by narration, and by written text. So, for example, on this slide, everything you're looking at down here, verbal information. This very crude sketch that I made of a brain at the top, visual information. My narration on the slide, verbal information. A crucial element of dual coding theory is that we need to make sure that the information we're passing through both of the channels has a high degree of meaningful overlap. The information needs to mean the same thing to the learner, even though it's represented in different forms. And we know that when a learner has a high degree of overlap in the information they are intaking through both the visual and the verbal channel, they're able to better relate those two streams of information into their mind and form a congruent mental model that helps them better understand our intended learning. And you can see on this slide, I have information verbally that I've written and narrated about the two channels, and an admittedly crude drawing of a brain with two arrows going into it to indicate the two channels. I want to show one more example that really gets to me, to the heart of what cognitive load theory is trying to accomplish, or what we're trying to accomplish with multimedia learning. And to do that, I need to tell you about the magic number. So the magic number is from the very famous paper by the psychologist George Miller, where he talks about our short-term memory and how many basically things or items that we can hold in our short-term memory at any one time. And Miller said the magic number was 7 plus or minus 2. So anywhere between 5 and 9 pieces of information at any one time. More recent research suggests that Miller may have been optimistic, and the number is put somewhere actually more between 2 and 4. So we might say 3 plus or minus 1 is our more modern understanding of the magic number. So when I show the next slide, I want you to try and remember the information that's on the slide. How long would you need to study to memorize this string of random letters? If I was to give you a test, how fresh in your mind would you have to have been studying these numbers in order to do well on that test? Now on this slide, you're looking at the exact same letters. They're just arranged into patterns that you recognize, and I've provided visual cues that can help you to relate the information and remember it. So if I was asking you to remember the 9 letters on this slide, how long would you need to study them to remember them compared to the previous slide? And if in a week or so I was to give you a test, how much more likely are you to remember these 9 letters than the 9 letters on the previous slide? And so that just kind of goes to show the ways that we can use imagery and that we can arrange information in such a way as to make it much easier to learn. This has been a quick look at cognitive load theory. Thank you for your attention.